Hello and welcome to today's lesson. Please make sure you have a place to be taking your notes. There is not a specific notes paper, but you do need to have a notebook paper or scrap paper to take notes on. So once you have your notes paper, our objective for today is that mathematicians, you all, can identify and represent patterns that describe nonlinear functions. So yesterday we looked at linear. Today we are focusing on the nonlinear. So first of all, nonlinear functions, what are they? Nonlinear functions are a function whose graph is not a line or part of a line, so it will not form a straight line. So just like linear functions, nonlinear functions can be represented with tables, graphs, equations, ordered pairs, all that stuff. It's just not going to form a straight line like it did yesterday. So as you can see in the picture here, linear, straight line. Nonlinear is not a straight line. You will notice even on the nonlinear functions, the graph all the way on the right, the graph that is just the dots, we have a V shape, and you will notice that the two pieces that form the V individually might look linear, but because it is one piece, one straight line is the definition of a linear function. That is not one straight line. It is two straight lines that are together. Therefore, it is not a linear function. It is nonlinear. So how can we look at and classify functions as linear or nonlinear? So we've got two things here, pizza area and the sauce cost of the pizza, and we need to classify them as linear or nonlinear. The area in square inches of a pizza is a function of its radius in inches. So as I look here at this first example, I see that when I look at the change in radius here, this is going up by 2. And when I look over here, I have 50.27 and 12.57. And that is going up by 37.7. Ran out of space there, but it's 37.7. And then 113.10 and 50.27 is going up by 62.83. So I already see that I do not have a constant, constant rate of change here. So I can already tell because of that it is going to be nonlinear. I can look at the sauce and do the similar thing. This is going up by 2 in the x values. And over here it actually does appear as though it is going up by 80 cents, by 0.8 or 80 cents each time, 8, 16, 24, 32. So this one does look like it may be linear. Another way that I can check this is by taking a look at the graphs. So I do have a picture of those here for us. When we graph the pizza area, graph the values that it gives us, it does actually end up being a curved line. And then when I graph the sauce cost, it is a straight line. So pizza area is nonlinear, whereas the sauce cost is linear. So go ahead and take a moment. Please pause your video, try out this question, and when you are done, resume the video to check your work. All right, welcome back. I have the answers here on the screen for you. You will notice that this got it question is a nonlinear function. The reasoning, the thinking question at the bottom, will the area in part A ever reach 0? The answer is no, because when you multiply a number by a fraction, it will get smaller and smaller and smaller, or the denominator gets larger and larger, which makes the fraction smaller, but it will never actually reach 0. So it is nonlinear and it will never reach 0. So take a look here at this next one. We again looking at nonlinear functions, looking for the patterns in them. And as I look at this, I am trying to figure out what the function, what the equation and the graph might be. So as I look at the values here, the number of blocks on an edge, the total number of blocks, and then writing those two values as an ordered pair, I'm looking for a relationship. So is it +1? Is it times 1, times 2, times 3? Is it somehow an exponent? I will give you a hint here that a lot of times nonlinear functions have exponents involved, and so that is a possibility here. When I am looking here, I notice that this is increasing by 1, but that over here we've got 1 to 8 is +7, and 8 to 27 is definitely not +7. It is, excuse me, it is adding 19. So that's not going to help me. So what can I look at? Well, like I mentioned, a lot of times nonlinear functions are including exponents, and so as I think about what this figure is showing me and how I'm looking at a cube and looking at the number of blocks that are involved or incorporated into that cube, I am going to think about cubing something and see if that helps me. So if I had these numbers cubed, my x values cubed, does that equal my y value? Well, 1 cubed is 1, 2 cubed is in fact 8, and 3 cubed is in fact 27. So I can use that pattern to help me out here and finish my table. That gives me 64 and 125, and that also helps me with my ordered pairs. And then I need to figure out, okay, is this going to be linear or nonlinear based on that and based on the graph? Well, I can already tell because I was looking for that constant rate of change and it was not constant. I can already tell that it's going to be nonlinear, but I can also take a look at the graph, which I now have here on the screen for you, and you will notice that it is starting to curve upwards instead of being a straight line. So please give this question a try. Once again, pause your video, give it a whirl, and when you are done, resume to check your answers. All right, welcome back. The answer is on the screen. If you do not understand how I got the answer, please pause your video and let me know, and I will be happy to explain it to you as best as I can. Now, when we think about functions, what is a function? We want to keep that idea in mind that a function can be thought of as a rule that we apply to the input to get the output. When you were in 7th grade math, or 6th grade math, it's possible that you talked about a function machine, looking at the rule that you apply, and that same idea applies here. So how can we write that rule when we have ordered pairs here? So I will give you, again, that hint. When we have nonlinear functions, a lot of times it does have something to do with exponents. So I'm first going to take a look here at my ordered pairs. I've got my x's and y's, 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32. So I am trying to find some kind of rule that I can write. I'm looking at these values. 1 to get to 2, I could say times 2. 2 times 2 does equal 4, but 3 times 2 does not equal 8, so that doesn't help me. It's not x plus 1 because 2 plus 1 does not equal 4. Is there something that works here? And as I continue to look, I notice that if I take the number 2 and apply the x value as my exponent, it does work. So 2 with an exponent of 1 equals 2. 2 with an exponent of 2 equals 4. 2 with an exponent of 3 is 8. 2 with an exponent of 4 is in fact 16. And 2 with an exponent of 5 does give me 32. You might be asking yourself, how in the world did you come up with that? It's just about looking for that pattern. It's trial and error, looking until you can find that. Try exponents, try multiplication, try adding, and see what works here. So my rule for this one is in fact y equals 2 with an exponent of x, or y to the power of x is the rule for this function. Okay? Please give this last question a try. Once again, do your trial and error, see what you can come up with as you give this a try. And when you're ready to check your answer, please pause your video. I'm sorry, please resume your video when you're ready to check your answer. All right, welcome back. Here is the answer for this last one. If you take your x value, your first number, and plug it into this, if you square it, you will end up getting this second value. So hopefully that one was a little bit easier for you to find. All right, at this time, that is the end of our video lesson for today. A nice short and sweet video lesson, but once again, you need to show me your notes in order to get the homework, and if you have any questions from the video or as you work on your homework, please make sure that you ask me.